failed because of the network. I will get it, and if it's there, I will put it on the. Well, it sucks, but
yeah, that's
it will
working.
stay there. This open source.
Okay. I needed to be able to see the slides to prompt me as I talk.
We still have 2 minutes.
Yeah.
It's recorded on the YouTube. It's streamed on the YouTube.
Yep.
So people are watching online. We have to start exactly the.
Yeah, it's fine.
Sentences we will introduce ourselves then. Also, you have scarves, so you can give out scarves.
Okay,
Yeah, they are there.
I'll try and remember to leave time for.
Nobody did. I mean, so try it.
Yeah.
We have
Okay,
a lot
that
of
sounds
scarves,
good.
you
I'll see if I can leave enough time.
And the only other just things to remember in case we cannot reach the person asking questions, if you can repeat it so that it's recorded.
Sure.
Nice to have so many people from Heat.
Yeah.
It's 14 here.
Yeah, there's been a few talks. So Jay did an introductory one earlier on, so this kind of follows on from that. So if people have seen the earlier talk, it will probably help.
Great. Well, I think it's actually very good for us to see that because I'm also working on supporting OpenStack.
Oh, awesome.
So the Heat is kind of complex.
Kind of.
Not kind of. It's,
Yeah, I mean,
kind of.
this is kind of one of the advanced use cases for Heat, so we go into some of the more advanced sort of features. It doesn't have to be complex for sort of, simple use cases, but it can get complex, I agree.
Yeah, the one I'm missing here is the dance leading for the networking.
Dan Sledden is here this week.
Is he?
Well, he was here for some meetings, but I haven't seen him yet today. I'm not quite sure if he stuck around. But
Okay.
he was here yesterday, I saw him. So
he's on the deadline. Or he's some
so we had some meetings at the office the last 2 days, but I think he should be around.
It's true.
Okay.
Hello guys, it's already time for our next presentation. I'm pleased to welcome Stephen Hardy, Principal Software Engineer from Red Hat United Kingdom. This next presentation will be about main components of TripleO, and we will have deep dive into Heat Templates. So it's kind of a follow-up on the previous Jay's presentation. So please let me welcome Stephen Hardy.
Thanks very much. Thanks for all of you for coming. It's good to see so many people interested in hearing about TripleO and deploying OpenStack on OpenStack. Where's the switch? Is that working?
No?
How's that? Can you hear me now?
Yeah.
Okay, let's try that again. So, as you heard in the introduction, my name's Steve Hardy. I'm a software engineer at Red Hat, and I've been working full-time on OpenStack for nearly 4 years. Quite a lot has happened during that time. OpenStack is a very, very fast-moving project, and I'm going to try and give you a bit of an overview of OpenStack, the various components, and we'll go into a bit of detail in particular on Heat and TripleO, which are the two projects that I'm currently most heavily involved with. So what are we going to talk about here? The majority of it is going to be talking about OpenStack. So it might be worth considering what OpenStack is for a moment. Obviously, it's cloud software, which a lot of people have heard about, but really it provides you with an abstraction layer. So if you have a data center and you want to be able to provide on-demand access to all kinds of different resources, not only compute resources running VMs, which is the use case most people tend to think of when it comes to OpenStack, but also storage and virtual networking and various other things which we're going to talk about in a moment. So we're going to try and give you a bit of an overview of OpenStack. We're going to do a bit of a deep dive into some more advanced capabilities of Heat, and this will follow on somewhat from Jay's introductory talk earlier on, so it would be good if anyone has seen that. If not, you might want to check out the recording at a later date. And then we're also going to talk a bit about Ironic, which is the bare metal provisioning piece of OpenStack, and how that can help us with the TripleO vision, which is using OpenStack components to deploy OpenStack in a production environment. So a few years ago, OpenStack was very much smaller than it is now. It was primarily focused around abstractions for compute, and that is mostly running VMs across multiple hypervisors, and block and object storage. Now, a few short years later, there are a large number of different projects. This may not even be accurate because I did this a few weeks ago. But as you can see, there are everything as a service is the way I like to think of it. Any conceivable abstraction in your data center is likely to have someone working on a REST API that allows people to more easily interact with those resources. So we're going to focus on Ironic, which allows you to do provisioning of actual bare metal hardware, so dedicated bare metal machines for your workload rather than VMs. And then we're going to talk about the Heat orchestration component, which allows you to have a more declarative interface to all of these different tools. You can see that if you've got this proliferation of different HTTP APIs, they all follow some common patterns, but they're not necessarily 100% consistent. There are different command line tools, although there is a common OpenStack client effort going on as well. But really, you need some way which is less imperative to define your resources in your cloud. And as Jay's talk introduced earlier on, there's a template model which he accepts, which allows you to define relationships between your different resources and instantiate them in the right order for you without you necessarily having to worry about dependencies between components explicitly yourself. So before we get into the details of the orchestration features themselves, it's worth kind of differentiating a little bit between orchestration and config management. This is kind of a bit of a blurry line, particularly in the cloud world, because there's a number of different config management tools that provide some orchestration capabilities, and then there's some more orchestration-focused tools which do have built-in config management capabilities. So Heat tries to draw a fairly defined line between those two features. We don't have any built-in software configuration capability, but we have implementation agnostic way to drive existing config management tools. So we'll get into a bit more detail about that, but I just wanted to clarify that, it's not a replacement for Puppet or Ansible or anything like that. It's really about organizing and managing your interactions between different services on OpenStack. So to follow on from Jay's introduction earlier on, the instantiated environment for Heat is a stack, and so that's the name for the resources which have been deployed for you by Heat based on the YAML template that you have fed in. If you're at all familiar with CloudFormation, similar kind of concept. We have a native template language in addition to capabilities to drive CloudFormation templates. And another really nice feature of Heat is that there's a very easy way to compose multiple fragments of your environment. So you can define a Heat template that contains, say, some particular piece of software and the server resource that is going to host it, perhaps some networking to support it, some particular type of storage, and that can be a unit that is then easily reused. The templates are all parameterized, and as Jay introduced earlier on, there's the concept of an environment. So say if you need a staging workflow and you need some different parameters or even different nested stack implementations between, say, pre-production and development and production environments, it's very easy to do that with a maximum amount of reuse. So this is just a very quick example. Try not to overlap too much with the earlier talk, but it's going to help with the concepts we discuss later. When we talk about composability, we're really talking about referencing one Heat template in another template. So it's kind of a parent-child relationship. So in this case, we've got a parent template which is referencing an OpenStack controller type alias. And that is just a way of referencing this server with controller config.yaml. And the way which you will create that is to reference the resource registry, which is just a mapping between an alias and an implementation. So you do your stack create, pass in a template and an environment file, and those two combine to fully define what's going to be deployed in your cloud. So once you've got your unit of deployment sorted out and you've got something that works really, really well, pretty much immediately the next thing you're going to need to do is to build lots of them. You're going to need to scale out horizontally when your application becomes successful because you're going to need to handle an increased load. So there's a couple of different ways of doing that within Heat. The one which I'm going to talk about primarily today is the resource group abstraction. And this just provides a really easy way of saying, make me however many of a particular resource type. And so you can combine that with the composability we just talked about and just scale out a Heat template to any number depending on the capabilities of the cloud you're deploying onto. There's also an auto-scaling group resource which has integration with ceilometer alarms, and that allows you to do much more event-driven scale-out. But we're going to talk about the more static grouping method today. So you've got your server stood up. Perhaps you've got some storage, you've got some networking set up. The next thing you're going to need to do, as we discussed earlier on in terms of config management, is deploy some application onto the hardware. The way you do this in the Heat model is basically you define a software config resource in your YAML template. And this doesn't care what tool you use. It just accepts, for example, a Puppet manifest or an Ansible playbook or a shell script or a Python script or whatever it is that you want to run on your server. You then reference that from a software deployment resource, and this is the thing that actually runs your config. This is the thing that knows how to associate that piece of configuration with a particular server. And there's a syncing mechanism, which is using some agents inside the instance, which basically knows how to collect that configuration, run it on the node in question, and then send a signal back when it's done, or if it fails. And we collect the standard out, the standard error, and the return code of whatever it is that you run. And the nice thing then is, it's well integrated with the templates. You don't have to do a handoff to another tool, although you could do if you wanted to. You could deploy with Heat and then configure with Ansible or a Puppet Master or whatever. But particularly in the case where you want to scale out, it's more convenient if you can define everything in one place and then just multiply up the environment as it grows. So another common requirement if you're deploying a more complex application, and in particular OpenStack, which is what we're going to be talking about deploying in a moment or two, is configuring each individual node is not enough. Each individual node can be set up, but then they need to be configured to know about all of the other nodes. And so I'm calling this cluster configuration because that's effectively what we're talking about. You deploy a cluster of near identical nodes, or completely identical, and then they need to be wired up so they can talk to each other. And the example we're going to talk about today is OpenStack controller nodes, where you install a bunch of API services and a bunch of RPC and database components, and all of them need to be wired together, otherwise they're not going to cooperate and increase your capacity as a whole. So you've got this nice configuration method. You've got your templates sorted out. You can deploy your workload on a virtual environment, and you're happy that it works great. But a lot of people have requirements for better performance. And this is where ironic bare metal provisioning comes in. So this is an OpenStack API that basically makes bare metal provisioning possible in a way that's very, very similar to deploying virtual machines via the Nova compute service. And in fact, it has a driver such that you deploy something in the exact same way that you deploy a VM, and then what you end up with is a bare metal machine. So the key difference between this and more traditional provisioning methods is that you don't run an installer. You prepare an image ahead of time, and then you basically deploy that image onto the bare metal node, and then you're basically ready to go. The advantages of there are, in some cases performance, but in terms of trying to make sure that all of the nodes are exactly the same and managing drift between different nodes, this can be a nice method as well. So there's quite a lot of support from the hardware vendor community. Ironic is proving to be quite a successful project. And so that's quite a good motivator if you want to build a deployment tool, if you already have built-in support for a bunch of different hardware. And so that's one reason why TripleO uses Ironic for bare metal provisioning, because it has very good pluggable support for different hardware types. So hopefully you can see that okay. This is just a diagram which tries to give you a bit more of a granular view of how things work inside Ironic. And so as I mentioned, so the Nova API in OpenStack is the compute interface. Traditionally, you would use that to launch VMs on, say, a KVM or Xen hypervisor compute node. But in this case, it's configured instead so the Nova scheduler knows how to talk to the Ironic API. And the user comes along and says, OK, I want a server running this image, and the flavor is a configuration that points to a bare metal resource type. And so it works in a very similar way to starting a VM, only we have an extra step because the Ironic conductor needs to know how to power on the physical hardware. And then we do that via a plugin of some sort, and in this case, I'm illustrating you might have an IPMI interface. That's quite obviously quite a common standard, which would know how to talk to your hardware and turn it on, and perhaps do some other actions as well. So you power on your node, and then the Ironic service is able to PXE boot a RAM disk onto that node, which then pulls down the image which you want to put onto the node. There's some code in the RAM disk that knows how to deploy that onto the local disk. Then it reboots the node, and then it comes up with the image that you want to be running. So that, in a nutshell, is what Ironic does for you. And the key advantages, as I mentioned, are the pluggability and the driver support that you get for free if you choose to use it. So TripleO is choosing to use Ironic. Several other deployment tools inside the OpenStack space and elsewhere, such as Bifrost, are using it as well. And so it's proving to be quite a nice solution for these sorts of bare metal provisioning cases. So this brings me on to the integration of these two pieces. So when you have a heat environment and bare metal provisioning capability, you can then deploy a complex workload. And OpenStack is one of the more complex workloads you can consider. As I mentioned at the start of the talk, things are moving very, very fast. And there's a lot of relatively complex distributed applications that all need to be configured in subtly different ways. And so you need a flexible and repeatable way to deploy that workload. The exact same problem exists for many other kinds of workloads, but TripleO is focused solely on deploying OpenStack on physical hardware. So it's a bit of a weird concept. It's kind of the chicken and the egg kind of thing. You start off with an OpenStack environment and you end up with another OpenStack environment. You can reasonably ask the question, how do you get the first OpenStack environment? The answer is, at the moment, we have some scripts that do a single node install and configure OpenStack on one node using Puppet. And then the exact same Puppet implementation is used to configure the OpenStack services on the production cloud. And so we've adopted some terminology here, which is worth kind of remembering because it ends up being in quite a lot of documentation and blog posts and things related to TripleO. So the deployment cloud is called the undercloud. And this is basically the small OpenStack that is used to bootstrap your production OpenStack. And then the overcloud is the production cloud that you would then deploy. At the moment, the tooling expects you to only deploy one production cloud. In the future, there's no technical reason why, other than probably a few hard-coded assumptions, that you couldn't deploy multiple overclouds. And that's definitely something which we would be looking to support more completely in the future. You can imagine that would be particularly nice in a developer environment where developers might want their own test environment, which is separate from other users doing testing, or in a pre-production test environment. I think that could be very useful in terms of the sort of staging workflow that you end up needing before rolling out things to production. So you have your deployment and management tooling in your small OpenStack, and then you have your OpenStack production cloud, which is the thing that is actually deployed by your undercloud. So if we go back to some of the heat concepts we kind of looked at very briefly a few minutes ago, That is grouping of resources, composability, which is the nested stacks, a stack which references another stack, and the software configuration. We can see a bit more concretely how those features combine to make this kind of deployment possible. So the undercloud is deploying groups of nodes, and unsurprisingly, seeing as I've already talked about this resource group abstraction inside Heat, we make use of that in order to deploy however many controllers you want. For instance, you will probably deploy 3 if you want an HA deployment, and however many computes you want, which is basically the hypervisor nodes that support the deployment of VMs. And there's 3 different types of storage node. So you can deploy Ceph storage nodes, which have the Ceph OSD component on it, Swift storage nodes, which allow you to scale out your object storage, and block storage nodes, which is basically if you have a requirement for a basic Cinder storage implementation and you choose not to back Cinder by Ceph. So we've now got multiple resource groups, and you can imagine these are all in one template, and that's actually how we do it. We've got an overcloud YAML template, which defines a number of groups of nodes, and you say how many of each you want. And then we create some nested stack templates which define each node. And that goes away, and it creates an OS Nova server. And as we've discovered, if you have Nova configured to create bare metal nodes via Ironic, you can just go away and deploy on bare metal. So we're making use of that integration. And then we're making use of the software configuration interface of Heat to, in some cases, run scripts to prepare the network, and in a lot of cases, run Puppet in standalone masterless mode. So that's kind of a weird concept until you get your head around it. There is no Puppet master, and all of the data used for Puppet is coming from Heat. And the way we handle that is basically the first thing we do before running any Puppet on the nodes is we deploy some Hierodata. And if anyone knows Puppet, you probably will know more about the details of Hierodata than I do. But we deploy a big map of Hierodata key value pairs, and then we run Puppet in a series of passes on the nodes in order to get the services fully configured. So this is an illustration of that process. This is not every step that we run because I wouldn't be able to fit it on one slide. But it hopefully gives you an idea of the conceptual process. So the first step, as on the previous slide, is you deploy the server, you do the initial configuration of each unit, which is being scaled out. And then the next step is you do a number of configuration passes doing the cluster-wide configuration, which is the interface which I described earlier on using the OS Heat software deployment group. And each one of those accepts a configuration which is, in most cases, a Puppet manifest. Everything's wired in a bit of a kind of Puppet-centric way in the default implementation, but we've been careful to keep the abstractions in place such that other deployment solutions would be easily plugged in. And in fact, there's an effort going on at the moment to deploy via Docker containers using the Collar containers, which is one of the container communities within OpenStack. And they've been very easily able to wire in deploying via Docker instead of having to use Puppet to configure the services. So the point being that if people are sufficiently motivated, they could wire in using any config tool they are invested in. But we've chosen to use Puppet as a first step because of prior experience using that tool. So this is a slightly more granular model, which kind of combines the workflow we described for Ironic and the TripleO deployment workflow. So you have an interface to deploy your cloud that passes in some templates and some Puppet manifests into Heat, and Heat then basically builds a big dependency graph. And this is kind of the main thing that Heat does. It really cares about dependencies between different components, and it passes the YAML model, and then inside the Heat engine, you end up with a dependency graph, which we then know how to walk in a certain order such that you create things in the right sequence. But as a user or an operator, you don't have to care about that explicitly unless there is nothing in the template which references between those two resources. So Jay earlier on mentioned there's a depends on directive. If, for example, you were just creating two completely independent servers and for some reason you knew they had to be created in a certain order, you can control that, but in most cases you don't have to care about that explicitly. And so the other thing that we're making quite heavy use of in TripleO at this point in time is Neutron. We're primarily using that as an IP address management solution. There's been some really good work done on network isolation. So this is quite a common requirement for production OpenStack workloads, where you want to deploy and keep, say, the storage traffic separate from the compute traffic, or the management traffic separate from some other category of traffic. And so there are a number of predefined overlay networks that can be defined, and we use Neutron to handle that. So, got a few minutes left. I'm going to attempt to run a demo. This is going to be live, and I'm running bleeding edge upstream code, so there's every chance it could go wrong. But I'm going to run this. It also runs quite slowly on my laptop, so what I might do is talk through a few things and get it up and running, and then we can break for questions, and then providing it doesn't fail horribly, we can go back and look at the result at the end of the talk. So, as you may have noticed, I didn't come in with a rack of bare metal hardware. So my workaround for that is to use virtual machines, which are configured to pretend to be bare metal. And Ironic has been configured to drive these basically via PXE, and then there's a PXE SSH driver, which basically uses SSH between the RAM disk and the Ironic service to control things. So this is not representative of how you would do a real hardware deployment, but it's a reasonable approximation for these purposes. And this is also the same environment that most folks would use for development, unless they happen to have access to a bare metal testing lab. And you'll notice that there's one VM already up and running. So we've talked about the undercloud, the management node, the small OpenStack, however you want to think about it. Just so happens that for reasons related to the tooling we use to create it, we call that instack. And if you create a default environment using upstream TripleO, or also the RDO community have the RDO Manager tool, which is based on TripleO. They're both nice ways to get up and running using TripleO, depending on how bleeding edge you feel like you want to be. And in this case, the instack node is the undercloud. So I've got a shell window on here. And let's have a quick look at some of the services which are running on here. So, Ironic represents the bare metal nodes. We've registered 3 nodes here. And these are these 3 VMs which are pretending to be bare metal. At the moment, they're all in a state of power off and provisioning state available. So that basically means they can be accessed by the Nova scheduler, and they're available to be provisioned to. We can see there's nothing running in Nova yet, and so as we talked about earlier on, there's this flow between Nova as the user-facing abstraction and the API that launches the nodes, even though they're bare metal, and Ironic, which is the back-end that manages the actual hardware deployment itself. And so Heat is the orchestration tool that's used to drive the whole process, and we haven't got any stacks up and running at the moment. So in order to make life easier for operators, you can drive this directly via a Heat command. It's a bit inconvenient unless you're a developer. So there's an OpenStack client plugin, and it's as simple as doing this. If you want to deploy an overcloud, you do OpenStack overcloud deploy, and then in my case, I've made a copy of the Heat templates used to do the deployment to my local directory. If you don't specify a location, it will just use a default location, which is user share OpenStack TripleO Heat templates. Okay, so this is where I cross my fingers and hope it all works fine. So you can see there is a warning because I haven't I haven't tagged any of these nodes in Ironic to say that they're going to be a controller or compute. They're just generic nodes. That's actually just a warning. And so it's going to go through and it's going to pick at random 2 of these nodes. The default is 1 controller, 1 compute. I would run more, but I'll run out of RAM. And then we get a lot of fairly verbose event listings. So these are events that are coming straight out of Heat, and it gives you a nice view of the progress of the deployment. Unfortunately, they're getting a bit chopped by the resolution of the screen. Sorry, I don't think there's much I can do about that without making it too small. But basically, it's going to go through and it's going to create a group of nested stacks. Each one contains 1 server and some software configuration. And then it's going to create a bunch of resources in Neutron. And then it's going to do a bunch of configuration passes with Puppet. And then, if nothing goes wrong, it will all be completed and we'll have a running OpenStack environment. So I've got another window here so we can just watch things as they progress. So we can see now that OpenStack overcloud deploy command has gone through and it's created a heat stack. And this is going to stay create in progress until such time as all of those nested stacks and all of the configuration steps have been completed. And when it goes to create complete, that means that basically your OpenStack deployment is completed. So, similar to Jay's demonstration earlier on, he did a resource listing of the heat stack. And so you can see there's quite a lot more in this case because it's a much bigger template. And you can see that there's a bunch of random script string resources, a bunch of virtual IP resources, and a series of config resources that are used to configure the nodes. If we now look in Nova, so we can see that Nova has launched 2 nodes, which ordinarily you would expect to be VMs, but because of the way which we've configured things, it's talking to Ironic, and it's going to spawn 2 bare metal nodes, which are, again, these 2 nodes which are configured to be dummy bare metal, for want of a better description. So we've started these 2 nodes. They're currently booting. They have already booted the RAM disk and have deployed a CentOS image which contains all of the OpenStack packages. So here we can see Ironic has powered on 2 of the nodes picked by the Nova scheduler, and we're going to have to wait a few minutes whilst this goes through, and then the Puppet configuration and other resources within the heat stack get created. So thank you very much. We've got 10 minutes to go, and I know, having tested this earlier on, that it's likely to take most of the remaining 10 minutes. So I would suggest maybe we break for a few minutes for questions now, and then if we have time, I'll come back to this in a minute.
You started with a command that shows pre-registered hosts. How do you create those? And is there any kind of service or hardware baremetal discovery that sniffs around the hardware and gets an amount of RAM?
Yeah, that's a very good question. So in this case, there's a tool, a script called instack-vert-setup. It's in the TripleO documentation and the RDO Manager documentation. It goes through and basically uses Versh to create the VMs, and then it creates a configuration file, which is just a JSON map, which contains the details required, an SSH key and an IP address, basically. For real bare metal, you would create that JSON file manually, and it would create, you would need things like, well, at a minimum, you need the IPMI credentials. But you may well choose to put other details such as MAC addresses and things in there. In terms of discovery, you need to be a bit careful about the definition. So we can't just go out and automatically discover random nodes on the network. You need to at least provide the IPMI credentials. But having done that, there's another part of the process that I haven't talked about today, which is doing node introspection. And this uses the Ironic Inspector service. And so this has been developed closely with the Ironic community, and it uses a similar process to the deployment where it boots a special RAM disk and then it runs a bunch of introspection tests and then pushes the data back, which is then used to populate things like the amount of RAM in Ironic. So the answer is yes in terms of introspection, but you do need to manually input the inventory for the nodes.
Just a small comment from our community here. There will be discovery process in the near future. It's not even remotely as easy as some people think, but discovery as well. Introspection works now.
Yeah, so Dimitri is one of the main developers on the Ironic Inspector project, and thanks for the clarification. It sounds like discovery will be a future feature, so that's something to keep an eye out for. Any more questions?
Do you do any kind of tree or something to fan out? Do you do any kind of fan out to keep like the glance images and the pixies from all saturating nodes? I mean, is that part of the orchestration you do?
Yeah, so I'm not sure if Ironic will put in like a random factor itself. It's not something that we do within the TripleO code itself. Again, that's something which Dimitri may be able to answer.
It doesn't like cascade? Yeah. When you're booting like 100 nodes or 200 nodes from a certain amount of images through a certain number of pixie nodes, you can overwhelm them unless you do some kind of cascading, or is there any kind of clever way to not overwhelm some of the source nodes?
Yes, thanks. You mean overloading network for PXE requests or overloading glance service? So first of all, we're using iPXE by default, which is HTTP based, so it's not that bad. It's TFTP based PXE. This process itself doesn't have any batching other than that. And as to deploying process itself, there are two options actually in Ironic. You can directly deploy every node from glance, which is essentially not from glance, but from Swift temp URL, and you can scale Swift pretty well. Or the second option, which is default for TripleO, is each node is exposed as an iSCSI share and is deployed from Ironic conductor. So the former option, which is not default, is probably much better at scaling. That's I know some people using. We can support both, we just don't pre-configure it.
I mean, in my experience, the way which people tend to want to deploy is start off with a relatively small deployment and then scale out. But you're right, if you wanted to deploy hundreds or thousands of compute nodes, for example, at once, you might need to. There are several interfaces to the TripleO Heat Templates that allow you to override and provide custom configuration. And you might do something like having a script that runs on all the nodes and waits for a random amount of time. So there's certainly, in addition to the scalability configuration that Dimitri mentioned, there's ways that you could do that if you if you had a reason to deploy a very, very large environment in one go. Okay, so only a few minutes left. Any more questions? Yeah. So the question was, if the undercloud, the in-stack node fails, will the overcloud be impacted? And the answer is no, it will be fine. Although if you were in the middle of doing a deployment, you probably would be in an incomplete state. But we've got documented procedures for backing up the undercloud node. And if you had some kind of disaster, you would restore everything from backups, including the database contents, and then you would be able to continue managing the cloud which is currently deployed. There are no requirements for the undercloud to be continually running whilst the overcloud is deployed. So providing you haven't got an in-progress action, you can take the undercloud down for maintenance. Perhaps if you need to do an upgrade of the undercloud to a new version, that's perfectly fine. You just need to schedule an outage window, make sure that no one's doing anything in terms of configuring the overcloud, and then you can take it down and everything will keep running absolutely fine.
One more question. Are the images that are being deployed on baremetal all the same for all the kind of hard node types, like data type? Or
So by default, they are, but they don't have to be. So in case anyone didn't hear, the question was, is the image deployed on the nodes the same for all the different types? So you can specify a different image per role. So for example, the OpenStack controllers versus the OpenStack computes. you do expect to be able to use the same image within a given group. So if you had completely different architectures of hardware within, say, your compute group, that could be a problem. So we don't currently support mixing, totally different architectures. But if you had a requirement for a different image between, say, the controller nodes and the computes, that would be perfectly fine. By default, we just build one, which contains everything though. Any more questions at all? Okay, that's probably the last one, and then we'll quickly see whether this...
is it possible to associate before the overcloud deploy an ironic node to a host name? So to say this MAC address or this CPMI node is overcloud controller 0, 1?
Yeah.
Is this new?
Yeah, it is. I've actually got a documentation patch up at the moment for TripleO docs, which hasn't yet landed. So there's two different ways of achieving that, depending on how much control you require. You can either tag a subset of the nodes in ironic with, say, this is a controller, and then you can guarantee it's always going to be a controller, perhaps because your controller nodes have more or less memory or something, or your Ceph nodes have a particular disk configuration. And that is data that can be derived from the node introspection process. And then we've got some tools that allow you to have matching rules, so you can have some automatically applied tags. But I think your question is more granular. If you want to say this node will always be controller 0, and the way which we do that is you, again, assign a capability to each node in ironic, which might be node controller 0, and then you use Nova scheduler hints to basically force Nova to always pick that node. And yeah, we've got a documentation patch up for that at the moment. In the future, there might be a more direct way of doing it, but Nova scheduler hints provides a workable solution at this point. So we've only got a couple of minutes left. I'm going to have a quick look and see whether this is progressed enough for us to see any more. Unfortunately, I think it may be running too slowly. Okay, well, I'm sorry, but it looks like the demo is going to take a bit too long to run due to being overloading my poor laptop. We could probably take, well, I think we're actually out of time, so I think we'll leave it at that. But thank you for listening, and I hope that was useful.
I think it's post-deployment right now, so...
Yeah, it's going to finish now, isn't it? Like 1 second after. On my test machine at home, it takes like 8 minutes to deploy, but it's a bit of a faster machine. And I think
we got the same issue. We have laptops, and just it's not easy to install undercloud and overcloud in it if you have 12 gigs of memory. It's not even. I mean, you need 2 gigs for the undercloud, I think minimum, and then you need for the overcloud.
Yeah, I mean, this is 16 gigs and it's only just enough, but at home I've got a 32 gig box and it all works a bit easier. But we're looking at ways of trying to reduce the RAM requirement.
We have some happy guy from NA who is now trying to install it, the undercloud and the overcloud on his laptop. He's very optimistic about it, so we'll see. Can you copy the presentations?
was very like without discussion about the differences. No, the differences. Without the discussion, it was very interesting. Without debating on which is better.
Yeah, we're not going to do that.
Thank you very much. Yeah, so.
Thank you. Sorry, I'll clear the stage.
We have
How you doing? Nice meeting you. I think we've spoken on the phone before.
Ah, cool.
About Swift deployment on TripleO.
Oh, good. Well, yeah, I'll let you get on with it. Good luck.
The battery is low anyway.
It will last. I mean, he will use this, and this is enough for the presentation.
Even one now. This should be even enough for one presentation.
Yeah.
But then we need to find.
After that, we will put it in the chat.
Yeah, that's what I was trying to do, but with two presentations.